Box plots. So once you know how to do your 5-number summary, we can draw a box plot from there. So there's just a reminder of what your 5-point summary is. So we have our lowest, our Q1, the median, which is our Q2, Q3, and our highest score. The box and whisker plot is made using those 5 numbers. So the first thing I always do when drawing one is I draw the 5 vertical lines, one for each one of those numbers. So the lowest score here, this is the lowest here. This line is your Q1, your Q2, that's a bit messy, sorry, Q2 in there for the median. This one's your Q3, and then our highest score. Okay, and that's actually what it asks us to do underneath. It says, consider the box plot. Notice that the scale along the x-axis is increasing by 1s. The 5 pieces of information we can now read from the graph are, and let's write them down here. So the lowest score, this little line here, the lowest score would be a 1. The Q1, the next line along, is 3. Yeah. The Q2, which is the median, is 6. Q3 is 8, and the highest score is 9. Okay, there's another message here about outliers. We did this yesterday though. So outliers are extreme values. In some cases, there may be a piece of data that is an extreme score. It is one in which is a long way away from the values of the other group of numbers. On a box plot, this is denoted with a small cross, and the whiskers is shortened to the next largest or smallest number. A number is an outlier if it is either, and these are our formulas again. So you have to identify it with these formulas. So remember, if you use the Q1 minus 1.5 times IQR, you'll get a score. Anything below that would be an outlier. And then if you use the second formula, anything above that is an outlier. And to show that on your box plot, see this little X out here? That 16 is an outlier. The next highest score after that must have been the 9, because we shorten our whisker down to the next highest score. So that huge outlier, which is so far away, doesn't make our box plot look completely unrealistic for where the majority of our scores are. Okay? All right, so examples. Number 1, consider the data. Are there any outliers? Well, let's put them in order first. So from smallest to largest, we're going to have 2, 3, 3, 4, 5, 5, 5. I think there's 3 5s. 1, 2, 3, yes. 6, 6, 7, 9, and 12. Okay, so even just looking at those scores, at the lower end, 2, 3, 4, 5, 2, 3, 3, 4, 5, I should say, probably no outlier down there. But the higher end, 6, 7, 9, and then there's a bit of a gap to that 12, maybe,
there is a 12.
Maybe that 12 is an outlier. Maybe. We have to check with our formula. So let's look at both of them, because we want to practice both formulas. We're going to need to find our quartiles first though, because we need the interquartile range for the formula, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 scores. Plus 1 is 13, divided by 2 is 6.5, which means it's between the 6 and the 7. So 1, 2, 3, 4, 5, 6, and 7 is between those two 5s. So that's my Q2, and it would be equal to 5. Not that we need that for the formula. Now, because the examples that I did yesterday, our median was always one of the numbers, and I circled it, and it meant that we didn't use that number. But because this one was between, I am going to use all the numbers to the left of that line to try and find the lower quartile. So there's 6 numbers below. Plus 1 is 7, divided by 2 is 3.5. So the third and the fourth number, in other words, 3 on either side. So between the 3 and the 4. That will be my Q1, which when you average those, 3 plus 4 divided by 2 is 3.5. Do the same thing for the upper quartile. between the third and the fourth one will be between the 6 and the 7, which will be 6.5. Okay, then I can find my interquartile range. IQR equals Q3 minus Q1. So my Q3 is 6.5. My Q1 is 3.5, which means my interquartile range is 3. It's a fair bit of working out for not much space in this question. I still need to use my formula, so we're going to try and squeeze that down the right-hand side there. So using the formula for the lower outlier is the Q1 minus 1.5 times by the interquartile range. So my Q1 was 3.5 minus 1.5 times 3. That's my interquartile range. So I think if you work that out, that comes out to be minus 1. Now, if I have anything lower than minus 1, it would be an outlier. I do not have any scores lower than minus 1. So no lower outlier. Let's try the upper one. So that's the Q3 plus 1.5 times interquartile range. Q3 was 6.5 plus 1.5 times 3. That makes 11. Okay, so anything above 11 is an outlier. Do I have any scores above 11? Yes. The 12, right? The one that we kind of looked at and went, it probably could be. It is. So I'm going to put that over here under my question. Therefore, 12 is an outlier. Part B, I want to draw a box plot. I've actually got all the information there. It's not written particularly neatly, but I do have all my quartiles and I can see my lowest and highest score. So my lowest score is 2, my highest score is 12. That's only a difference of 10. Now, when you're drawing a graph, even a box plot, it's a graph, you should have a scale, measured scale. Okay, so you should be using a ruler. And I'm going to use every centimetre. So 1, no, it's not going to let me use every centimetre. Okay, so my smallest number was 2. Going to do every number, counting up. 2, 3, 4, 5, 6, 7, 8, 9. I mustn't have counted right before. I have to get to 12. I need an extra spot. That's a bit dodgy. Not very straight, that bit. Yours will be nice and straight. Okay, so my 5-number summary. I'm going to have my lowest score, which was 2, so I put a line. My Q1 was 3.5, so between the 3 and the 4, put a line. My Q2 was 5, put a line. My Q3 was 6.5, put a line. By the way, make sure they're all above. We do put these sitting just slightly above the axes. And my highest score is an outlier, is a 12. So remember, if it's an outlier, we put a cross. If our highest score is an outlier, it means my last line needs to be at the second highest score, which was a 9. So I need another line here. Yeah? So the middle 3, I join the top together and the bottom together to make the box. And then from the center of each end, we draw lines coming out to the highest and lowest, which we call our whiskers. Box and whisker plot. Anyway. Okay, so there it is. Next page for question 2. Once you've got that all drawn in. Everyone ready? All right. Question 2, we're going to do much the same thing, except for that we have a stem and leaf plot. So for the following stem and leaf plot, it gives a speed of 25 cars caught by the roadside speed camera. So the stem, we've got a key up there. So the 82, it means it's in 82 kilometers per hour. So the first part is telling me just the units, kilometers per hour. The second one, the 8 star, that is telling me, see how I have an 8 and then an 8 star? Normally we only have one stem and we work in tens. But when they put the star in there, it means it's splitting that lot of 10 into the 5 lower and the 5 higher. So this will be from 80 to 84, and this will be from 85 up to 89. It's splitting it. Otherwise, these would be a very big stem for each of those, all right? So splitting it into groups of 5, classes of 5 if you like, rather than having the full 10. All right, so we need to find our 5-point summary. Count through how many scores do we have in that stem and leaf. You just want to count the leaf up. So 1, 2, 3. 25? Did you guys get 25?
Yeah.
Okay, so to find the middle, we definitely do not want to be crossing off beginning and end. That's too confusing. So add 1 is 26, divided by 2 is 13. So let's count through to the 13th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to circle it there. It's the 9. It does mean that that's the number 89 because you need the stem in there. All right, so that means that I have 12 numbers, because I'm not using the 9 now, 12 numbers that are lower than that. What's the middle of 12? 6.5. Plus 1, divide by 2. Means you have 6 on either side. So it is 6, but that means 6 below and 6 above. So 1, 2, 3, 4, 5, 6 means it's going to be between that 4 and the 5 that's on the next line. So I'm going to put my working out down below here. My lowest, my Q1, Q2, Q3, and highest. Okay, the Q2 I already worked out was 89. And I'm currently working out my Q1, which is between the 84 and the 85. So I average them, divide it by 2. So that's going to be 84.5. Okay, let's do the upper quartile. So there's 12 scores up there as well. So that's going to be between the 6th and the 7th as well. So 1, 2, 3, 4, 5, 6, and 7 is going to be between 94 and 95, yes. Oops, there's no point in there, 95. So that is 94.5. My lowest score is 82, and my highest score is 114, correct. Is that 114 an outlier? When you look at that stem and leaf, it looks like it probably would be. It says it in part B. It says draw a box and whisker plot of the data and identify any outliers. So let's do that on the far right hand side again. If I'm trying to find an outlier, first of all I need my interquartile range. So interquartile range equals Q3, which is 94.5, minus the Q1, which is 84.5. So that equals 10. Then for the lower end, we do Q1 minus 1.5 times interquartile range. So that is 84.5 minus 1.5 times 10. Okay, so that's 69.5. No, my lowest score was 82, so I definitely don't have anything that small. Okay, let's try the upper end. Q3 plus 1.5 times the interquartile range. Q3 was 94.5 plus 1.5 times 10. So that is 109.5. So I definitely do that 114 is an outlier again. So let's write that over here. Therefore, 114 is an outlier. Okay, so I've identified that. So now I'm ready to draw my box and whisker plot. I have scores from 82 to 114. That's a lot. So I've got to go from 80, 90, 100, what have we got, like a scale of 40 in there? So maybe I could go up by 5s. You did? Cool. You did 2s, depending on every half centimetre you could do 2s. Is that what you did?
Yeah.
Yeah. Awesome. All right, so grab your ruler out. So if you go up every half a centimetre, so it's going to start with 82 there. All right, that's going to be 84, 86, 88, 90, 92, 94, 96, 98, 100, 102, 104, 6, 108, 110, 112, and 114. Perfect number of spaces. So I have an outlier, which means I'm going to put a cross on the 114. For my 5-number summary, I have my lowest at 82, draw a line. Q1 was 84.5, so just slightly past the 84. Q2 is 89. Q3 is 94.5. And because my highest score is an outlier, I need my second highest score, which is 102 for my last line. So I draw a box to join all the top of the middle 3 lines and the whiskers from the center of the box out to the ends. Okay, there is one last question there. It says, describe in words the distribution of the data. Now, we've talked about skewness a little bit, but in here you can talk about clusters and you can talk about outliers as well. So we mentioned the outlier. We have an outlier at 114, but most of our scores are clustered or grouped, that means, between the 82 and the 102. Okay, so that's what I would write in there.
Do you write it as positively or negatively skewed? Or the cluster describes?
The cluster kind of, you could add that in there. Normally, if it might actually mention in there to comment on the skewness if it specifically wanted that. You could add that in there. Yep, it would be positively skewed. Yes, good. Most of the scores are clustered between 82 and 102. So I'm going to put that in brackets. Positively skewed.
It's on the left side.
Yep, that's right. With an outlier at 114. Okay, that's it. That's all we're doing today.